The data that you will see today actually follows through on what we have done in tutorial 1. But since it is Chinese New Year, so understand that we don't have tutorial. For those who haven't done so, please check the Telegram group. If you haven't completed or if you haven't attempted tutorial 1, please for now you can run the tutorial 1 quick SQL file that I sent. This one will give you the state of the database that is expected at the end of tutorial 1. So at least you can follow through the tutorial today because we will follow the schema that was updated after tutorial 1. If you notice, the last question in tutorial 1 actually makes changes to the schema, and that changes will follow through to the discussion today. Okay, so please make sure to do so. If you don't know how to use pgadmin, please Google that while we have the tutorial today. Okay, feel free. Okay, so since we have been 2 weeks since we have discussed about SQL joins and SQL queries, let me just do a very quick recap. I will not go through some of the more obvious ones, but then I will show you what are the more useful ones and how do we use the joins in the appropriate manner. So you might have seen this picture quite a lot of times. If you, for some reason, if your Chrome has detected you are taking 2102 and your Instagram pops up SQL memes, probably you will see this photo. Okay, this is actually one of the most comprehensive way to describe joins. But in some sense, it doesn't tell you what happens on the database. It only tells you roughly which table is taking which, but it doesn't show you what happens behind the scenes. So what I'm going to show you today is actually what happens towards your rows. Okay? In a way that it will help you understand when do we use which join types. Okay? So just a very simple one. I'm going to use a very simple database consisting of 2 tables. One is a fruit and the color. Then second one is dishes and their colors. I take the most iconic colored dishes here. So if I want to find inner join is essentially I want to do intersection. Okay, for the examples I'm giving here, I want to match them based on the color. Okay, so if I want to inner join fruit and dishes based on the color, then what I'm going to see is now I have fruits. I want to see which fruit has a color that matches the color on the dish. Now I see that, oh, red matches. Then I'm going to only take these rows. But notice that now apple is red, Bosch is red. So now this will be one pair. Strawberry is red, Bosch is red. So this will be another pair. Okay, so now notice that this will actually be 2 separate pairs. Okay, so these rows will now be intertwined. That is basically your inner join. Okay, it's not just simply taking intersection of, okay, this one is red, this one is red. But then it will actually find out apple is red, Bosch is red, one pair. Strawberry is red, Bosch is also red, one pair. If I put anything else, say like, I don't know, paneer makhani is red. If I combine this, then this will be another apple, paneer makhani, strawberry, paneer makhani again. Okay, so this will be multiple intertwined rows for those that actually match. Okay, so that is your inner join. Any questions? No? Okay. Next, we have our cross join. Now my question is, what is the difference of inner join and cross join? Anyone? Actually, if you realize, cross join is among the one single join that doesn't put any conditions. You don't put any on keyword when you do a cross join. Okay, solely because cross join is not meant to find any matches, nor is it meant to find any mergers. All it does is essentially, now I have, these are my 2 rows. These are my other 2 rows. I'm going to take the Cartesian product. If this is A, B, C, this is 1, 2, 3, then I will have A1, A2, A3, B1, B2, B3, C1, C2, C3. So now I will have every single combination of 2 rows, 1 row from the left, 1 row from the right. That is essentially my cross join. So just like this is already cross join without any conditions imposed. Okay, but once I impose a condition, then I can actually simulate a cross join similar to my inner join. Why is that so? If I put a where clause now this is exactly what will happen if I have inner join. Okay, this query is exactly similar as if I put an inner join. Okay, so a cross join with a where clause is similar to having, I can put inner join here, under the condition that all the where clauses are just ends. If it's all, then it will be more complicated. Okay, so in a sense, we say that cross join is kind of it's more powerful in a sense. Okay, so we would prefer cross join over inner join solely because the syntax is way cleaner. I will show you later in one of the tutorial examples where we have about 10 plus lines of queries. Okay, any questions for cross join? Okay, now comes the tricky one. We have a left outer join. Okay, I think this is the tricky one, but then it's quite powerful because it has a greater expressive power over your normal cross join, if you remember from the lecture. Okay, so what it does is essentially I'm going to do a left join of fruit against dish. So fruit, left join, dish. That means my fruit is on the left. Okay? What I'm going to do now is I want to see first, visually inspect which one actually matches. I see that my fruit now, I have my apple, I have my strawberry. These two matches with the bosch because the color is same red. But then I have grape and blueberry, they are not red. They don't have any matches. Okay? Nor is there anything on the right side that is purple or blue. Okay? But instead of throwing the grape and blueberry outside, I will still keep the grape and blueberry. I'll merge those that have matches. Those that don't have matches, I'll put now. Okay? So when we say left join, means that we've only focused on the left table. The left table entirely will still be there. Those with matches will be matched. Those without matches will be left with nulls. Okay? So that is your left join. Now you will notice that when we use left join, this will already introduce null values, even when you clean your data such that there are no null values. Okay? So that is the tricky part of your left join. Any questions? Now same goes with the right join. When we say right join, that means the right table is now maintained. Okay, so we see the right table, your dishes. Your dishes, your bosch actually matches with two dishes on the two fruits on the left. So when I combine them, you see now the bosch will have two matches, right? But then these two that are unmatched, they will still remain the same, but the left side now will have nulls. Okay, so notice that when we do right join, now the right table is the one that remains intact. Those that don't have matches are still there, but the one on the left, when they don't have matches, they're already gone. Okay? Because it's a right join. That's the main difference. So now the question is, what is the difference if I do dish left join with fruit versus fruit right join dish? Who says they are the same? Dish left join fruit, fruit right join dish. 1, 2, 3, 4. Okay, more hands. Who says they are not the same? 1, 2. Okay. Why is it not the same? Duplicated entries? I mean, is the result the same between these two queries? Not the same because of the duplicated entries. Position of the null values. Actually, if you notice what I did was I changed, right? If I do dish left join fruit, then my dish is on the left, it will be intact. Fruit right join dish on the right, so it will be intact. So actually the values will be the same, but are they the same? You, any guesses?
Why would it just
Is it the same or not?
the values of the condition?
Okay. So actually, the values are the same, but it's just the column ordering will be different. Okay? Because now you see that when I say left join, dish left join fruit, the dish on the left will still be intact. Any matches will be there. Okay? Basically, inner join plus those unmatched will be null. If I do fruit right join dish on the right will be intact. Okay? So this will be intact still, but it's just whether the dish on the right or the dish on the left. So the ordering will be different. If your goal is to determine the name or you want to get the dish name, then both of them are okay, the same. The problem is when you want to apply things like union, select, union, accept, or intersect, right? Where the column naming doesn't matter, this will introduce bugs because now the ordering is different. When you want to merge two things together, this will be a problem. Okay? So just to take note of that. Yeah, but aside from that, right, since they are the same, no one actually uses right join. The only time I use right join was in this tutorial when I prepare for this. I never use right join. Yeah, so just use left. Okay, so full outer join, same thing, but now we will see these are matches between left and right tables. No match, we will still remain intact. Then on the left table, those that have no matches will put null on the right. Right table, those that have no matches will put null on the left. Okay, so this is basically your full outer join. It's essentially left and right joined together. Okay, any questions so far? So just to quickly summarize, this is basically the 5 joins that we discussed. Natural join, I will not discuss. I think that one quite obvious. So yeah, the important part is noting that inner join and cross join will not give you any null values. But left, right, and full outer join, this will give you null values. Might give you null values under the cases where there are no matches. Okay, so just to keep that in mind. Essentially from these 5, right, Normally, I will just use these two because you can simulate your inner join with cross join. Plus, you don't need a right join. You can just use left join. Full join, I don't think I have used this before also. At least not in this module. Okay? So actually, you can survive just with these two. Because I can say we can survive just with these two, that is where I will give you a very quick quiz to determine which of these two should you use. Okay? Question. Suppose this exact class, on this exact use case, I have two tables. One is a roster of every student in this class. Second is I have the list of attendance that was scanned by the QR code just now. Okay, so the roster consists of your NUSNet ID, your name. Then the attendance will consist of the NUSNet ID as well as what time did you record. Okay, so my goal is for every student in this tutorial, I want to get the time that you record attendance. The question is whether I should use cross join or should I use left join on the NUSNet ID. Okay, I repeat. I have a student with NUSNet ID and name, attendance with NUSNet ID and recorded time. I want to merge these two tables together. I want to get for every student in this tutorial, what time do you record your attendance? Okay, so in my end goal is I want to select name, comma, recorded time. Okay, should I use cross join or should I use left join? Who says cross join? One? Who says left join? 1, 2, 3, 4, 5, 6, okay, 7, 8, okay. Okay, I think more left joins. I think the rest are still digesting. Okay. Actually, there are no wrong answers here because I set this as quite ambiguous as possible. Two answers are possible. Under the condition that we assume every student actually comes to the class, then every student will be mapped to the attendance. I can use cross join. Okay? But that is under the assumption that every student attends. Or, if the goal of my application is to see only those who attend, what are the recorded times, then that is the moment I use cross join. But if my goal is to see, if I want to have such that those who doesn't come, this will be null, then that is the moment I have to use left join. Okay? Most likely this will be the case. Okay? Because the way I specified is just I want to see the time. But I don't specify whether it's only for those who attend or something like that. Okay? But if you have an exam, this will be already very specific. This is just to illustrate when do you want to have null, when do you not want to have null. Okay? So it's whether to choose null or not. Okay? Any questions so far? Doubts? No? Okay. Okay, then just a brief through on the set operations. I think this one is quite self-explanatory. We have three set operations. We have a union, we have an intersect, we have except. These three correspond to normal set operations in your set theory, I think. Yeah, this is basically just your union, intersect, and also set difference. Okay, same thing. But it's important to note that two queries must be union compatible for the set operations to work. When we say union compatible, it means that they have the same number of columns, same domain, meaning the same field type, data type, and it should be in the same order. Okay? But they don't have to have the same column name. That is why just now the moment you see the dishes, right, all four will have the same data type. Different ordering, once you merge, this will give you the wrong data. Okay? So that's why ordering will be very important. When this happens, although it's very convenient, this will introduce bugs, whether you like it or not. Okay? Okay, then if no more questions, now we'll move on to the tutorial problems for today. Today we are going to discuss both simple queries as well as the algebraic queries. For the simple queries, for now we will limit ourselves to using simply cross join because we will use all the where and the and clauses for simple queries. First one, we want to print out the different departments. If you don't have this in your schema, that means you haven't done tutorial 1 because this is at the end of tutorial 1. Okay. So now we have a department table. The department table consists of a department as well as the faculty. We want to print out the different departments. How can we do this? So let me just show you the department table. This is exactly the department table. We want to get just the department. Okay? I think this one is quite self-explanatory, very simple. All you need to do is to just select the department column from the department table. Okay? So do note that here, there is no requirement for us to put a distinct keyword, solely because inside department, this is already a primary key. When we have a primary key, that means that there will not be any two rows with the same value for that primary key. Hence, it is already unique. So we don't have to put any distinct keyword. So just doing this, select the department from the department table, then this will give you exactly the number of exactly the departments. Okay? Any questions on this? Quite easy, right? Okay. Now next question. Now we have the student item. I think I haven't dropped the faculty table, faculty column here. We want to print out the different departments in which the students are enrolled. So we want to get out the department. How do we do this? So the department there is linked to the department table. Yeah, we just want the department, sorry. Okay, so let's see the student here. If I try to show the students, now see these are my students, then I have the departments. Okay, now my question, can I just put this thing? I'll copy the exact same thing from the previous solution. Now I choose the student department from student S. Does this work? This one I haven't fixed. Does this work? Select S the department from student S. If you run it, gives you something. But what's the problem here? Duplicates. Okay? Because what it does is, essentially, I have my students. Even in this class, we have a lot of CS. Once I only strip out the department column, then I will have a lot of CS, 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 CS. But my goal is to find out the different departments of the students. Or in particular, in my class, I want to get only CS, CEG, and DSA. I don't want to get CS, 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 CS. Okay? So to do that, then I will have to put what keyword? Distinct. Okay? So by selecting the distinct keyword, then I will get exactly what we want. Okay? So this is a choice of whether you want to use distinct or not. When you have duplicate values, or when that key is not a primary key on its own, that is the moment you have to use distinct. Okay? Again, depends on the requirements. Here we are required to put different. Okay? Any questions? Okay. Now I'll spend a bit more time on part C, because part C is more complicated. So let us check the integrity of the data. We want to print the emails of the students who borrowed or lent a copy of the book before they joined the university. Okay, so now I have two schemas here. First is the student table, then second is the loan table. Okay, now what I want to do is to find out for students who borrowed or lent a copy before they joined, I want to show the email. Okay, so my target is going to be this email here. But then notice that the loan itself doesn't put the student year of entry. The student year of entry is contained here. Okay, so I want to compare these two fields together. Okay, I want to compare these two columns. One is the year, one is the borrowed. But these two columns come from different tables. So I want to have some way of combining this. But I have to think also, these two tables, how are they related? Okay, that is why I will have to look through the data. If you look through the loans here, maybe I'll show. Yeah, student I think I showed just now. If you look through the loans, you will notice that the loan borrower and owner, these are actually student emails. Okay, while they are not foreign key or while they are not any references, right, I can actually still kind of like infer some connections because I can filter things out using that, right? Okay, so in a sense, I will say that, okay, these two things can be connected. They are not foreign keys, maybe, but then I can filter something to see if the student email matches this. Then obviously, this is the student. Okay, so that is what I'm trying to do here. So I want to combine these two tables together by comparing the owner email, borrower email with the student's email. Okay, so since my concern is to find out the students who borrowed or lent a copy, then I will see whether the borrower email is the same as the student email or the owner email is the same as the student email. Okay, so that is where we will use this technique called cross-join. One table, combine them. Now I will have every single combination of two rows possible. Okay, so you will see here, if I do a cross-join, select star from student S, loan L. Now, my table itself is already combining. This is my student table. It's paired with every single row from the loan table. Okay, but obviously I cannot directly compare here because you see now the student is Hui Lin, but then the borrower is Wei Xiang and Hui Ying. Now I cannot make any meaningful comparison. So once I do the cross join, that is where I will have to start to filter out which rows are my interest. Okay, first one is I want to select only the rows where the email either matches the borrower or the owner. Okay, that way I can compare the year with the borrowed already. Then I will just compare. Once I get that, then I realize that, hey, once I get whoever is the resulting, right, this student may borrow more than one book. In that case, then the email may actually occur more than once. So that is where we will have to select distinct emails. Okay, so let's try to simulate here. So this is my cross-join item. First one is I want to see out whether this email is equal to the loan borrower or the email is equal to loan owner. Once I have this, now you will see this is Hui Ying. Hui Ying, okay, well, it doesn't match the borrower, but it matches the owner. Now I can compare the years. Okay, so once I do that, now let me just put a bracket here, or else now they will take the Boolean precedence. So once I do this, then I will have another clause, and I will compare whether the year itself. So the student year is actually a date, it's not a year, if you notice. So the student year, or maybe the loan borrowed date, so L.borrowed, happens to be before the student's year of entry. This is the result. Okay? So if I only select the student's email, now you will notice that I will have lots of duplicates. Poof. Now you will see this Anupama so many times. Okay? We don't want that to happen. So that is where we will have to add another keyword called your distinct. Then now you have the exact result. Okay? So if you know what to imagine with the data, then you can construct your query. Okay? All you need to do is to actually see what is your target, how does it connect, and what additional criteria do you need. Then you can construct your query quite well. Okay? So this is your query. Any questions? Okay. Now, for each copy that has been borrowed and returned, we want to print the ISBN 13 and the duration of the loan. Order the results in ascending order of ISBN 13 and descending order. So while I provided the book schema here, actually you only need the schema for the loan only, because this book value, if you see the loan, this book is actually already the ISBN 13. Okay, so if you just check this one, loan is already, actually this is your ISBN 13. So all I need to do is to just print out the ISBN 13 as well as the duration. But then, there might be something that you have to take note of. Okay. So the problem is this. This is the main problem. You want to find out the duration, but then inside your data, some of the books haven't been written yet. They might be borrowed today, so they haven't been written, obviously. So this will be problems where you cannot compute their duration. Okay. So there are actually two ways of approaching this. When your return is null, it depends on how the question wants you to approach. But since the question doesn't really specify, there are two ways we can handle. First one is obviously we can just omit values where return is equal to null. Okay, so we just need to put additional clause here where return is not null. Then we compute the duration. The duration can be computed by setting return minus borrowed plus 1. So this is a derived data. Okay, so we just get a derived field here. Now the question, why is there a plus 1? Say if someone borrows today, returns today, it should be counted as 1 day. Okay, that's why there's a plus 1. Okay. Any questions? Now the ordering part, I think I don't have to describe this. This one quite obvious. Okay. Now there's another way of interpreting. Under the case where you still want to consider books that haven't been returned to count as the duration up to today, so the next day when you run the query again, the day will plus 1. That is where you will put this extra keyword called coalesce. Okay, so coalesce, for those who don't know, this is quite similar to getting a default value. This is telling you that if return is not now, then it will give you the return value. Else, it will give you the current date. So it's like a default, get or default in 2030 for those who have taken. Okay, so let me just show you real quick here the main difference. If I just do the, where is it? Yeah, if I just do this one, you will notice that I have 3,300 rows. This is by omitting the null values. But if I actually get the coalesce values, oops, now I have 3,393. So that's the 90 plus values that are now considered. Because now I don't omit the null values, but I consider them to be returned up to today. Okay, so that's the duration of the loan. So that depends on how you want to interpret. There's another way also to use cases, but I will not go through this. You can read this on your own. This one is, I don't think anyone would want to use this anymore. Why would you use a complicated case when you have a clearer way of using coalesce? Okay, case is useful when you don't want to check for is now. If it's is now, then just use coalesce already. Okay, any questions? Okay, now last one. For part E, I will be spending a bit more time here. So for each loan of a book published by Wiley that has not been returned, we want to print the title of the book, name and the faculty of the owner, and name and the faculty of the borrower. So this one will be a bit more brain visualization because we are handling quite a lot of tables. In particular, we are handling 4 main tables. Your department table, student table, loan table, as well as your book table. The target values are, we want the title of the book over here. You want the name of the owner, the faculty of the owner, name of the borrower, faculty of the borrower. So I pointed out in orange, these are my target values. Next thing is we want to see how are these tables connected. I noticed that this borrower and owner, these are student emails. Student department is connected with the department name. These are the same values, so I can match them. Book, loan, this is your ISBN 13, so it's kind of connected to this one. Okay, so these are my connections. On top of it, my condition is that the book must not be returned yet, so it's still being borrowed. Thus, the return value must be now. Then it also must be published by Wiley, so the publisher must be equal to Wiley. Okay, so you see how this will be a bit more complicated. Okay, so here is the additional problem. Now notice that I cannot just simply manipulate things with just these 4 tables, because I want to get the name and faculty of the owner, name and faculty of the borrower. If I only use one single student table, then when I get the email, there's only one email, but I want to get the name and faculty of the owner, name and faculty of the borrower for one row. Then that's not possible, because the owner and borrower will completely be 2 different persons, right? Okay, then that is the moment I will have to consider one separate student data just for the owner, one separate student data just for the borrower, so that I can match them. On top of it, because one student data has its own, then I will have another department table for the owner, another department table for the borrower. That's exactly where this gets complicated. You have to cross-join loan, book, student for the owner, student for the borrower, department for the owner, and department for the borrower. So in total, we will play around with 6 different tables here. But once you understand how to separate the rows, it's actually quite easy. First one is we will filter out, see which student email matches the owner's email. So now I already isolate this is the owner student row. Once I get that, I get the owner department, match it with the department table belonging to the owner. Then I get the faculty. So this is the owner's faculty. Once I get that, I have another student table for the borrower. I match the email with the borrower email. So now this is the borrower row. I get the borrower department, match the faculty. So now this is the borrower faculty. Okay. Then finally, I just need to match the books. At the condition where the return must be now, so it hasn't been returned yet. And finally, the publisher must be Wiley. Okay? Understand? Here on the rows, right? If you are clear with this, then you won't have problem with understanding what's the actual solution. It's quite long. Okay? So this is the actual solution. But if you are able to break down the fact that the top one, the select, is actually the targets, the orange rows. These are my 6 tables that I cross-join, and these are the conditions. Then this is already quite clear to understand. Okay? So again, my concept in queries is just if you can imagine what happens to your data, you can write the query. As long as you have to be able to see what are you looking for, how are they connected, and what other conditions must be met, then you can construct this. Okay? Any questions? No? Okay. Then now we'll move on to algebraic queries. In fact, this is actually easier. Okay? First one is we are going to rewrite that long query, but now we are going to use inner join. How do we do so? It's actually quite simple. Notice that this part, the blue ones, these are basically the one that connects between tables. These ones are additional constraints that are needed by the question. Okay? Since these part are the one that is connecting, then I will have to convert the connections. Instead of using where, I will use inner join on. Okay? It's quite simple actually. This same item, but I will copy paste exactly. These are the conditions. Replace them by inner join, which table on something. Then I'm done. Okay? This is why I'm saying that cross join can actually be used to emulate your inner join here. And in fact, if you see in the queries here, right, if I go to this one, this is my cross-join solution. Oops. Yeah, this is my cross-join solution. It has 10 rows. This is my inner join solution. It also has 10 rows. But the difference is, now your cross-join is actually quite simpler to see, because now all of these are just your clauses. Compared to the inner join, now all the inner joins are separate down, so it's actually difficult to see what tables are you trying to combine. Okay, that's why we try to utilize cross-join whenever possible. Okay, any questions? Okay, now I'll go hantam directly 3 questions, B, C, and D, because these are very related. So B is we want to print out the emails of different students who borrowed or lent a copy of the book on the day they joined. Third one is borrowed and lent. Fourth one is borrowed but did not lend. Okay, naturally, what keywords will come to mind? B, C, and D? Union, intersect, except exactly. So B is actually if you can get the borrower emails who borrowed on the day they joined versus the owner emails who lend the day they joined. Okay, this is just union, this is just intersection, and this is just set difference. Okay, so now let's try to construct the query together. Now let's try to get what is the item here. Let's try to go to this one. Question 2, yeah. So if I want to get, let's say, the email of the owners, so from student S, loan L, where the student email is equal to the L, the borrower, and the student year happens to be exactly the same as the loan borrowed date. So this is those who borrowed. Then I can also have this thing called the those who lent. Okay, now I give you a funny thing. Let's say I change the first one to be, let's call this Messi, let's call this Ronaldo. Obviously now the columns will be different. Can I combine them? Can I use union on them? Why? Union compatible conditions are same number of columns, same data type, same order. We don't care about the name of the columns. Okay, so the moment I do this, oops, I have an additional semicolon. This works. Okay, this is why it's very convenient, but then it also introduces possible bugs. Okay, if the key word here is union compatible doesn't mean you should combine. Okay, one is you can combine, but it doesn't mean you should combine. Depends on the context. Okay, so this is basically the first item for part B. For part C, it's just change this to intersect. Part D is just change this to accept. Then you are done. Okay, so that is essentially your question 2, B, C, and D. Okay, so B is just union. Do note that when we do set operations, union, intersect, and accept, we don't have to put distinct keyword because by default they already remove the duplicates for us. Part C is just intersect, and part D is just accept. Okay, but before this, I want you to take a step back. Can we do this without doing set operations? Okay, so let's see. Now I want to print out the emails of different students who borrowed or lent a copy of the book when they joined the university. In this case, actually, it's quite simple. It's quite similar to question 2C, where all you need to do is you just do a cross join between student and the loan. You see whether the email is equal to borrower or the email is equal to the owner. Then the borrowed date is equal to the day that they enter. Okay, so in fact, this is also still possible, except the fact that now you have to put an explicit distinct because it doesn't remove the duplicate for us. Okay, it's exactly the same as your 2C, except 2C was the borrowed date was before the year. Now this is, as 1C is, this is less than. Now this is equal, exactly the same actually. Okay. Now, when it comes to set intersection, it's a bit more complicated because now when you want to get the students who borrowed and lent at the same time, you cannot just simply use one student table. When you use one student table, it's referring to saying that this student borrowed and lent the same book, which is not possible. You cannot just use one single loan table because now you're trying to say that this student lent and borrowed the same book, which is not possible. Okay, so in that case, you will have to put two different loans to show you that there will be two entries, or maybe at least one entry where the student borrows and lends. Okay, so this is the key difference because there won't be any possible case where the student will loan and borrow the same book. Borrow the same book at the same time. Okay, that's why we will have to put in two different cases. Except for the last one where we do set difference, unfortunately, this is no simple query solution. Okay, so one key takeaway from today is actually you can survive this tutorial with just cross join, left join, and accept. Actually, it's possible. Okay, okay. Now last question. We want to print the ISBN 13 of the books that have never been borrowed. So how do we do this? I think this one is also quite obvious that we can use a set operation. If I can get the list of ISBN 13 from the books, we can just subtract those that are within the loan. Then this is already a set operation. Okay. I can get the list of ISBNs from the book table, subtract this by the list of ISBNs from the loan table, then I'm done. Okay. In fact, this is quite an elegant solution. Select book ISBNs, accept, select loan ISBNs. Okay. Question, why do we not put a distinct here? Or must we put a distinct? This is not distinct, by the way. This is not distinct. You will have duplicates, duplicate book ISBNs in this loan. The reason why it's okay for us not to put distinct is because we are doing A except B. So our goal is to find out, to exclude things within A that are found in B. Okay? That's why it's okay not to put this as distinct, because this is not the key part that we are trying to seek. Okay? That's why it's okay. But now we try to take another step back. Can we do this without a set operation?
Use not in. Use not in.
Not in? Not in. I would suggest against in. In is a bit slow. In is actually a bit slow. Okay, outer join. How do you use outer join?
Select for L, right auto join would be. Then you just check where the L borrower is now.
So you do a lone right join on
ISBN for L.
lone right join on book. Okay, yeah, that actually works. Yes, that actually works. In fact, yes, I will reverse a bit. I will use a left join. Exactly the same as your idea. Okay, so this is where a left join would be quite useful. If you want to try to imagine what happens behind the scenes, I will give you a very quick database to imagine, right? Say this is my books, this is my loans, okay? If you notice, these items are distinct. These items, they might be duplicate because the loan itself has a composite primary key. So the book itself might not be distinct, but the combination of book with something else will be distinct, okay? So in this case, if I try to do a left join or book left join with loan on the ISBN, then you will have this. Okay. Now A has been loaned multiple times, so this will have multiple matches. C has been loaned, but B and D has not been loaned, so this will not have any matches. Okay. Since our goal is to find out the books that have not been borrowed, then we just need to see which rows have null values. Okay. Remember that the book ISBN will not be null on the loan side, right? So in this case, we just need to see out which ones actually are null on the which book values of the loan is equal to null. Then in this case, this will tell us what are the books that have not been borrowed. Okay. Now, if I want to get just the ISBNs, then I will just select this one. Now my question, do we put a distinct here? Select distinct B.ISBN 13. No. But clearly just now I have multiple A's here. Why do I not put a distinct? So this one is a bit tricky to explain. First of all, I'm just trying to clarify that there's no harm in putting distinct unless the question says otherwise. Okay, it's okay to put distinct unless you want multiple values, then there is a wrong answer. Okay, but the reason why we don't have to put distinct here is because first of all, ISBN 13 on the book is already unique. Okay, that's the first thing. Second thing is when we do the left join with the book, with the loans, right? What happens is those with matches, they might be multiple values, but those with no matches will only occur exactly once, which has the null values. Okay, so if we only select those with the null values, then these items will only occur exactly one per each row. By default, the book is already ISBN 13 with unique, so it's okay for us not to put distinct. Okay, so no distinct is needed because ISBN 13 is already PK. Despite there might be multiple ISBN 13s in the resulting cross join, When we filter out only those with no l.book values, then that's the moment this will still be unique. So it's okay. Okay, any questions? No? Okay. So this tutorial is actually trying to illustrate to you the fact that you don't have to constrain yourself to one single method. There are multiple ways to obtain the same query, but sometimes we might constrain ourselves to one method also. In fact, I actually constrained myself to one method. Back in 2023, I called myself a left join warrior. Solely because I enjoy left join so much. The fact that the midterm has 8 questions on queries, I used 4 of them on left join. I'm not penalized for the left join, by the way. Yeah. So left join is actually very helpful in a sense that while it is dangerous to have nulls, there might be cases where you want to have nulls. For instance, if I want to get who among my students didn't attend my class, then I will just use left join. Or how many times do students attend my class, right? There might be students who are not recorded in the attendance. That's where I will use left join. I can coalesce the attendance to 0. Then that is very, very useful. Okay. So I hope by this tutorial you should be able to understand when do you want to use the null. Then that is the moment you want to use a left join. Okay. Other than that, then that's it for this tutorial. Make sure to scan the QR code for attendance. Then if you're done, feel